When we discussed phase transitions previously, we showed that this coincided with a case in which the difference between the molar Gibbs energy between the two different phases was equal to 0. We also observed that this occurred when there were changes between delta H and delta S. So this coincided with what we call discontinuities in delta H and delta S. Or in other words, as we go from one phase to another, the enthalpy and the entropy would change in a discontinuous manner. Okay? To be precise, we refer to this sort of process or this sort of phase transition as a first order phase transition. So this type of phase transition is referred to as first order. And so some examples of a first order phase transition would be the typical ones you think of: melting from a solid to a liquid, boiling from a liquid to a vapor, or sublimating from a solid to a vapor. Okay? And so those are the typical types of processes when we think of a phase transition. However, there are exceptions to that rule. Specifically, there are special types of phase transitions in which the enthalpy and the entropy changes aren't discontinuous, but rather they change smoothly over the phase transition. Okay? So are continuous, but while the delta H and the delta S values are continuous, their derivatives are not. So their derivatives are discontinuous. Okay? Right? And so for these types of processes, these are known as second order phase transitions. Second order phase transitions. Okay? All right, and so in this case, rather than delta H or delta S being discontinuous, it's their derivatives. So for example, if we take the second derivative of the Gibbs energy, molar Gibbs energy, with respect to temperature, we know that's equal to the negative of the derivative of entropy with respect to temperature. Right? And by definition, that is the constant pressure heat capacity divided by temperature. Okay? Another example would be if we took the second derivative with respect to pressure. Okay? So that would give us this. And we could relate that to the isothermal compressibility. Or if we took a mixed second derivative, that would give us this relationship. And we could relate that to the isobaric expansivity. Okay? All right, in any case, for a second order transition, rather than delta H or delta S being discontinuous, really it's these sort of properties that are discontinuous. So the heat capacity and the compressibilities. So these would be discontinuous for second order phase transitions. Okay? All right, and so some examples some real-life examples of a second-order phase transition. Perhaps one of the more commonly known ones is the glass transition temperature. And so here, this is the temperature upon which material like a polymer material that's non-crystalline goes from the solid state, where it's non-crystalline, into the liquid state, where it starts to flow. If you measured the enthalpy or the entropy of the polymer over this transition, you wouldn't see a sharp change, but rather you would see a sharp change in the heat capacity of the material. Another sort of transition that's second order is the ferromagnetic transition. And so this is when materials are heated above their Curie temperature, and so they go from being ferromagnetic to paramagnetic. So the magnetic properties of the material change. Right? And so in general, there's different types of phase transitions we deal with. First order are the most common, but second order are, as we start dealing with more complex materials, second order transitions are also observed.